Okay, so if Q, here we go. If Q is less than KSP, this system is not at equilibrium, so you would get, it's unsaturated. So if it's unsaturated, would you have a precipitant?
No.
No precipitate. Okay, that is still, just like in the other one, that's still a shift to the right. Okay, so it's still shifting to the right, and it means that we're forming ions, meaning it's soluble, right? Shift right, and ions are formed. If it's Q is equal to KSP, you are a saturated solution. Will you get a precipitant? No. Okay, you just say it's at equilibrium. If Q is greater than KSP, you're supersaturated. So you, yes, will get a precipitant. And just like before, if Q is greater than Q is greater than K, you still get a left shift. But now you're forming the solid, which is on the reactant side, right? And the solid is your precipitant. Okay? So just like before, you still have to say Q is greater than KSP, so you get a precipitant, or Q is less than KSP, you don't. KSP, you do not talk about shifting left or shifting right. Okay? You talk about forming a precipitate or not forming a precipitate. Okay? Okay. So here we have metals. Y'all can read through that. Sometimes we're going to get, yeah, let's just do the problem. It's just easier to show you, okay? So here, here we have a solution prepared by adding cerium nitrate to potassium iodate, and it wants to know, will the cerium iodate precipitate from the solution? Okay? And it gives you a KSP value.
Cerium is a real thing?
Yeah, it's 58.
That sounds so weird.
It's one of the intertransition metals in the F block. Okay? So first thing we need to do is calculate the concentrations that we have of everything. Okay?
So we're finding Q.
Yes, we're going to find Q and compare it to KSP. So in order to do that, when we mix these things up, we got to figure out their concentrations. Okay? So here we go. This is going to be a long problem. We got to calculate the concentration of cerium. And this is initially what we have before we mix it. Okay? So we have 750 milliliters of the 4 times 10 to the negative 3 molar. And we're going to divide that by the new volume, because that changes our concentration. 750 plus 300, because that's what we're mixing it with. You don't have to, normally when we do volume times molarity, we need it in liters, but because we're going to have milliliters on the top, milliliters on the bottom, they're going to cancel out, so you don't have to.
Is that like saying on like the C? Initial, the zero.
Initial, it's the initial concentration, it's actually not the initial concentration, it's the concentration at the reaction. I don't know why it's there, just leave it. Okay, so that gives us 2.86 times 10 to the negative 3 molar. So now we need to do the same thing for the iodate. So we have 300 mils of that. Two times 10 to the negative molar, and then the new volume. Here's what a lot of kids forget to do, is divide by the new volume. Because once you mix them together, their concentration has changed. And then that comes out to be 5.71 times 10 to the negative 3. So now calculate Q. Now, do we triple the concentration here?
I don't think so.
You're correct, but why don't you think so? Explain why.
Because that's for like the very end.
Yeah, we calculated what concentration we have there, so we just plugged that in. But we do cube it, right?
Yes, ma'am.
Yeah, we do cube it. And we get a Q value of 5.32 times 10 to the negative 10. So Q is greater than KSP, so precipitant will form. Did I just spell that wrong? No. Yes, I did. No, I didn't. Okay? What time is it? Okay, we have this last problem is a long problem. This next problem is really long, so I'm going to work that with you. I'm not going to make y'all work that by yourself. Okay? Any questions on what I did there and why I did it? The key to remember there is adding the volumes to get a new concentration. That's key. Okay? Okay. Yeah, I'm going to have to just get myself a new page. I can't fit it on here. Okay? So, exercise 6. Okay? It says you prepare magnesium nitrate and magnesium and sulfur fluoride. Calculate the concentrations at equilibrium with the solid MgF2. And it gives you a KSP value. So the first thing we have to do before we do this is we have to determine if a precipitant's going to even form, because that'll make a difference in our concentration. So that's the first thing we need to do. Oops, sorry. So first, determine precipitant. And I'm going to just do that for precipitant. Okay? So we have to figure out our magnesium concentration. So we have 150 times 1 times 10 to the negative 2 divided by our new volume of 150 plus 250. And that'll give us 0.00375 molar. And then do the same thing for fluoride, excuse me. And that gives you 0.0625 molar. So now let's calculate a quick Q. Oops. Remember to square fluorine. So we get Q is equal to 1.46 times 10 to the negative 5, which is greater than K. Q is greater than K. So, yes, we get that. All right. I'm going to let y'all catch up because y'all are y'all still writing? Then I'm going to stop and let y'all catch up. Okay? Caught up? So now we need to figure out their concentrations at equilibrium. So let's do that. We have magnesium. We said a precipitant will form. So we're going to show this way when the precipitant forms, right?
Yes.
Okay. So remember when we're doing rice tables, we actually can't be in concentration. We have to be in moles. Okay? So when that happens, before we form this, we have to go back to the original concentration. So for magnesium, you're going to have the 150 milliliters times the volume times molarity. Okay? And I'm going to introduce something to you to make the calculations a little bit easier because it works with better numbers. It's called a millimole. No. So like, you know how you have a milliliter is 1,000 milliliters equals a liter. Millimoles is the same concept. So if we did, so that what that basically means is I can multiply the milliliters times the thing and get, yeah. So it works out to be 1.50 millimoles, but you cannot read that. Does everybody have the top part? Because I'm going to give a new screen because I'm running out of room. Just this. I'm going to I'm going to restart the bottom. I'm asking if everybody has the top. Okay. So we have Mg 2 plus 2F minus going to magnesium fluoride, and that's your solid. Okay. So if you take, to get moles, you do volume times concentration, right? It will come out to 0.0015 if you do that. But we can make that millimoles. You don't have to, but if we make it millimoles, it's just easier to do the math. And then volume times concentration for the fluorine comes out to 0.025 moles, so we're going to say 25 millimoles. And then, of course, this is 0 at the time, because this is initial. At the change, we can only make as much as what? What's our limiting reactant there?
The magnesium.
Magnesium. So our change is going to be minus 1.5 minus 1.5 times 2, because of the 2. Okay?
Wait, 2F. It's 2F.
Yeah, isn't it F?
Yeah, it's 2F.
But,
So the 2 keeps going throughout.
So this is the, yeah. And then this means we're left with 22 millimoles.
oh, just 1.5.
Mm-hmm. Yes.
The 1.5 is what you're
Because we can't, right here,
limiting reactants.
that's the limiting reactant. So we can't make more magnesium fluoride than we have magnesium because it's the smallest one. Right?
Will our grader understand the whole millimole?
Yeah, that's a yeah, it's common. If you don't want to do millimoles, you don't have to, but it does make our math easier. I mean, why wouldn't they understand a millimole? Milli means 1,000 of anything, right? Yeah, I can have a milliliter, I can have a milligram, I can have a millimole, I have a milli, whatever. Yeah. Okay? Okay.
A million.
Is there a millifoot?
No, because that's metric in English units. Okay. All right. So now,
Milli-inch?
so now we can figure out our fluorine concentration here, right? Because we have 22 millimoles over the additive volume, which was 400. When you add them together, right? 400 milliliters. So our concentration at this point is 0.055 molar.
And it's now molar, not milli, because we divided by the
A mole per liter is the same thing as a millimole over a milliliter, right?
got it.
Yeah, so it's 0.055 molar. Okay? Okay, there is more to this problem, but we will not have time to get to it, so I'm going to have to stop here. But I want to make sure you understand to this point what we've done. At this point, what is the concentration of magnesium at this point?
2.1 times 10 to the negative 4.
Nah, it's 0. All of it precipitated out.
What is that the answer?
Now we're not done. This is at this point. We got another step, but I don't have time to finish it, and I don't want to end at the bell. Okay? So I'm going to stop the video here. To be continued.